Hello, everybody. Welcome to this week's episode of Deploy Friday. I'm Robert Douglas, your host. I have a co-host with me today from Platform.sh, Ori Pekelman. Wave, Ori, please. Right, great, thank you. And we have two guests today, Boris Mann and Brooklyn Zelenka, who are going to show us the future of the internet. You saw it here first. Now, the way that this show is going to work today in this amazing revelation presentation to you is that Boris is going to take the first part of the show explaining what fission.codes is. Brooklyn's going to take the second half of the show explaining what Boris just said to you, and Ori is going to interject with wild excitement every time he hears something that's really cool. Are we down with the ground rules for the show, everybody?
Sounds awesome.
I'm just going to say, wow!
Exactly. That's what we hired you for, Ori. So if this is fission.codes, you can check it out, as you watch or later. Got the URL there. We'll keep it up there for a second. And with that, I'm simply going to hand over the floor to Boris Mann and ask simply, what is this?
Awesome. Thanks, Rob. Thanks, Ori. So Fission is an edge app publishing platform. And we'll get into what that means a little bit. So what we've done is we've given developers a stack of tools, identity, files and data storage, basically everything that's needed to run a full web app using only the front end. So no back end and no DevOps. And we include things like privacy and end-to-end encryption and portable data. And that's done because generally these are things that are very hard for developers to get right. What we see is a real challenge where you walk into the equivalent of a Home Depot, a home improvement store, where there's tens of thousands of cloud components and APIs and everything else. And as a developer, you want to build a house, an app, and you have to go in and you have to pick and choose all of these different things, and you have to hope that they fit together. And in fitting those things together, things like privacy and encryption and making sure that things are portable really are incredibly hard for an individual, a small team to pull off regularly again and again. So the vision for Fission is that we have a toolkit, an SDK that runs at the edge. You have a great experience for developers putting apps together, which in turn leads to a really great experience for users. Their data is private, their data is encrypted. Their data can be used between the apps that they use rather than trusting that a developer has backed things up. And it runs in their browser, all browsers, including mobile browsers. And making it so that these things work offline as well. That's one of the hallmarks of things like edge apps. We've also included a CLI, a command line interface for developers. We think it's pretty great. It means that you can develop locally. You don't have to learn Git if you don't want to. You can publish directly from the CLI. And we've got DNS and SSL and other platform features that are just expected in 2021 and beyond. One more piece I'm going to add, I know that's already a fair bit, is we feel pretty strongly that we have to move to more distributed architectures. One of our building blocks that's pretty key for us is the Interplanetary file system, or IPFS. And so what that does is all of the files that we use in our system are content addressed. And we'll get into that a little bit more later. But that's a key that everyone can participate in hosting things, including your browser, and have a really powerful CDN where things just work without having to worry about where they're located.
So assuming it was a really tall building, that was a great elevator pitch. So what I took away from that was that one of the essential features of an app that you build with Fission is that it's decentralized. So maybe we should take a step back a step up and look at that. Brooke, would you maybe explain to me and to us, the audience, why is it important to move to decentralized apps? What's wrong with the world right now?
Yeah, absolutely. I guess a big caveat to begin with. So there's a class of apps called decentralized apps, or dApps, and this is not in that category. That's like a very specific term.
DApps.
These are not
the
dApps.
dApps you're looking for.
These are not the dApps you're looking for, exactly. But the architecture is fundamentally distributed and edge. So we basically took the slider of, well, how does this live on a server or does this live on device, and cranked it all the way to on device. So as things are moving forward, devices, your phone is getting a lot more powerful, and we're always continuously more dependent on them, interconnected, all of this stuff, right? And it's there's only so much performance you can get by pushing things over the pipes, right? You have to deal with latency, et cetera. So we can get extremely, extremely low latency by pushing everything to compute right on device. And from a just general complexity layer, cloud architectures are getting massively, massively complex over time, right? So we took a step back and said, well, how can we simplify this? I basically want to have running live for everybody else what I have running locally, right? I've got my nice development environment going. It's live reloading, all of this stuff, and it's running on my machine. I want to just share that with other people. How can I make that happen? And today you have to immediately learn how to set up a server, deploy it, manage a database, all of that. And that comes with, as Boris was saying, lots of problems, especially around things like how do you do identity and data security, and if somebody gets into your server, it's just game over. How can we make it so that just comes all straight out of the box? And it doesn't matter where it's running. You could run it on a server, you could run it directly on your phone or your laptop, or some mix of in between, and it doesn't fundamentally matter, which then gets you all of those benefits. Easy to deploy, easy to run, automatic updates, and identity security and auth right out of the box.
So I think one of the things to point out here is that decentralization is not a goal. It's in fact part of the architecture that then other benefits fall out from. So we had a really great call with, we do Thursday Tech Talks most Thursdays, and James Long built this app called Actual Budget. And he said some really great things around this. So things like local first, which you get from decentralization, is fast. Performance is a feature. And so it's the some of the things that we get from going decentralized that's interesting for us.
Yeah.
But by the way, I just deployed my first Fission Codes app.
Amazing.
And so the thing was, I only started installing stuff when you started speaking.
No way.
So that was the constraint. So at least we can say, hey, you know what? There's a live thing running. Doesn't look much interesting, but that works.
Awesome.
It took 9 minutes, Ori? Really? That long? Wow, that's nice. Good. That means that if anybody's out, I'll share the URL one more time on the screen here. If you're watching this and you've got itchy fingers, you could see if you could use the rest of the show to deploy your first app. So there it is. So you said something, Brooke, that I'd like to build on and learn more about, if you wouldn't mind. Can you talk a little bit more about the identity and authorization features of Fission? Because it sounds like it's fundamentally different than what we're used to.
Yeah, it is. It's built in a way that's it's built. The high level is it's built on top of JWTs, but it works a little bit differently. So we're mostly
JWTs. I'm the person here who says what?
Yeah.
What?
JSON Web Tokens, which gets used in a lot of systems, especially OAuth. So we've essentially built a decentralized OAuth or distributed OAuth system. So we're used to working with access control lists, ACLs, where it says, you have some, literally a table, and it says this person is allowed to do these, have access to this file, sure, right? Or this table in the database, et cetera. And those rules get really complex really fast, right? In the simple case, it's really great, and say, oh, well, this person's allowed to access the rows that have them as the, the owner, right? Owner ID or something. But as soon as you get into roles and teams and all of these other possible use cases and all of the exceptions, well, I want to give access to Boris to just this one document, right? How do I build those rules in? And that all depends on some central server. So you're always making these network requests saying, hey, can I have access to this data? And thus all the data has to live behind that wall, right? You essentially have a guard standing there saying like, oh, are you on the list? Yep, you're on the list. You can have the thing. That does not work as soon as you push the data to the edge, to devices. Even Google's been bumping into this as a problem. Having everything going through the same central auth server at Google scale stops working. So they have a similar system called macaroons, where they still have a central auth server, and then it delegates out permissions to YouTube and Google Docs and all those things, which then can delegate access down to users. So it ends up breaking that up a little bit. We took that and pushed it to right down to the user. So users have self-signed certificates that end up looking a lot like an OAuth token, right? But where it's a full description of what that user, whoever is holding this, is allowed to do. And this is called OCAP, or Object Capability Model. So you now can go somewhere and say, look, here's my certificate. It says that I'm allowed to do the thing. And it doesn't matter who that is. You can always prove that you're allowed to do that. And then they're in order to do the security on that, they're all, cryptographically signed, and there's a few pieces in there too that are all handled by the SDK. But it's fundamentally now not the list exists somewhere and it's hidden by some group that has everybody's on one list. It's everybody has their own certificate that they can go around and show, and they can also show to each other or delegate some rights of those to somebody else. So I can say, hey, Boris, you're allowed to see these documents and hand those off to him, or you're allowed to write to these things.
So an example actually of this that, Rob, I will also be the person who goes, here's another analogy that is less technical, which is, so OAuth and similar things and ACLs are like, you need to hand someone your house keys. And pretty much they just have access to your whole house at that point. So you're using an OAuth to Twitter. They've got a few pieces of granularity, but they're essentially you. They're holding your keys for you. And in this model, you can delegate permissions to an app, and that app in turn can use a bunch of other services directly and sub-delegate things. It also makes architecture differently, where you're not calling back to one central thing. Things like agents and bots and other things that live at the edge. And of course, offline as well, where because these are cryptographic proofs, where basically, one of Brooks' sayings is because math is why it works.
I was going to say, it starts to sound a little bit like non-fungible tokens and something with blockchain underlying. Is there truth to that?
I think what's really interesting is obviously blockchain, and Brooke and I spent a fair amount of time working with the Ethereum blockchain. And a lot of advances in cryptography are coming from the activity in that space. And these are some of the similar things. And IPFS that we mentioned has keys and a few other things built into it as well. And so these are sort of fundamental computer science pieces that are being integrated. And I think the other piece, actually bumping all the way back up, this is, of course, how things like iCloud and Apple work. They have your device with a secure enclave that keeps keys on it. And we're definitely very interested and model a lot of our things on how Apple has built things, where things are local on device, they're secure, they're encrypted, and trying to put that together as a set of capabilities for developers, where we kind of say, hey, we're gonna be here in the middle a little bit, and conceptually in the middle, it's all direct between people, and make sure that there's a good user experience that includes high levels of security.
Yeah.
And again, I think probably. Oh, no, I think it's been like 13. I mean, it's been quite a while where many of us has been talking about the decentralized everything, right? The decentralized web, decentralized social, and it's all broke, right? On one thing, user experience. It was always that. So it's really interesting that the man in the middle, or the persons in the persons in the middle, only for the user experience in a way, because right, in this model you never get to see the keys.
Mm-hmm.
Exactly. Yeah. Exactly. So there was a really good post just in the last week. The title of the post is actually giving up on open source software by Rommel is his handle. And he talks about this concept of lithification, which is a horribly complicated word. But I talked about like the Home Depot with all the bits and pieces that a developer has to pick from and integrate. And so what Rommel argues is basically that we have to start integrating. Another word for lithification might be vertical integration, where you need to design these pieces so that they work well together if you expect everything from user experience to privacy and security to be kept. And that's kind of our approach. Everything's on standards. You're working on specifying it. It's open source. It can be reused, but it's designed to work together for both user experience and security. And arguably, security is user experience.
Yes. Yeah. Absolutely.
And I have a feeling. Tell me if I'm wrong, but I have a feeling that there's a very strong intuition here around the idea that applications and data are one the same, in a way that basically like that we're used to a world where we kind of separate those, like there's the coding part and then there's the data part, and probably this is the moment in which DevOps happen, because data is hard. Apps are fine. Data is hard, and you're trying to bring those closer together, such as that maybe you can just drop the other one.
Yeah, I mean, this is a very old idea in computing, right? Going back to Lisp, code as data. And you're right. Today, with sort of traditional architectures, there's this dynamic thing called code, and there's this static thing called data, and they're fundamentally separate. And yeah, absolutely, this says there's no distinction. You're still transmitting your page and all of its JavaScript and functionality and WebAssembly and all of that as data across the wire. And can you do things like self-modifying pages and self-modifying code? Absolutely. There is no fundamental distinction there, because these can now, with this kind of an architecture, run literally anywhere. Right?
So what's really fun about this is we're just starting to get to the point with our own publishing platform. Our platform itself is used and built around these same things. So anything that you see, like our dashboard that you log into, is just an app running on our architecture that you give certain permissions to. And because of that, we actually expose things like the ability to create and publish apps to apps. So a developer can write an app that a user uses that in turn lets them publish new apps. Apps are the atomic unit in our system, and we generally mean web apps by what we mean by this, where you can add a custom domain, you're an owner of it, and various things like that. So you mentioned Joe Armstrong. So we're doing some work with Jeremy Rustin, who's the creator of TiddlyWiki, and we've been working with him to fission enable TiddlyWiki. So there's a mode where he's working on static publishing, where we'd like to get to, where people can run this TiddlyWiki app, and then they can hit a button and actually deploy an entire new site from the browser, because all of these capabilities are available where you've delegated the capability to be able to use your publishing platform credentials to publish new apps, which is pretty cool.
So we went over a very important point fairly quickly, and I'd like to back up to it, and that's the IPFS, the Interplanetary File System. Apps and data go hand in hand, and the concept of fission is very strongly based on the idea that the data is both local, but then exposed to the interplanetary file system, which has both concepts for public and private data. Which of the two of you would like to take a stab at explaining that better, and maybe walk us through an entire life cycle of what a file or a piece of data experiences if I create it in my browser where my app is running, and then somebody else wants to see it or use it? How does that even work?
I'll take some of the user experience pieces, and Brooke can peer under the hood for us. So IPFS doesn't today have the concept of private data at all. That's one of the things that actually set Fission on its journey. IPFS today is thought of kind of like a CDN. Underneath it works a little bit like BitTorrent and Git together. It uses a concept called content addressing. So let's say we have a photo of me called boris.jpg. And if we put that on IPFS, it gets a content address based on the contents of the file. That address or hash is unique, and think like number of atoms in the universe kind of thing of the namespace that's available. But it's also a global or interplanetary. That boris.jpg will be unique. I have put it on IPFS on my machine, and yes, there's a copy on my machine, but then as it gets requested, that file is actually broken up into smaller blocks, which is how BitTorrent works as well. So those can be anywhere in the network. If someone requests it, it will transmit in those blocks, and then they will then be available anywhere. Rob, if you take that photo and then put a funny red clown nose on it, it's still called boris.jpg, but if you upload it again, it'll get a different content address because the bits have changed. But not all of the bits, because of course it's...
Sorry to interrupt, but does that mean if I had simply uploaded an exact copy of it, that the IPFS would recognize that and kind of like dedupe and treat them as the same addressable content?
Correct, down to the block level. So every little piece of that. So the clown nose and perhaps the compression would have changed 20% of the image. But the other 80% of it would actually be the same sub-blocks that are still available. So they're not replicated twice onto the system.
Wait a second. Does that mean that every web developer on Earth would be using the same spacer GIFs?
Absolutely. Absolutely. It has some really... So you don't have to cache bust your CSS files, potentially, if you do natively over IPFS, because they would have to different address automatically, right? And that's the difference between location addressing, example.com, boris.jpg, which isn't even guaranteed to be a JPEG. It could be a PHP file or malware or anything like that. So in these times of misinformation, it actually says, this is absolutely the piece of data that I meant it to be.
Can I ask, does it also mean that if I just had a file that was like full of 0 bits, right? It's 0 bits all the way down, that would compress it to basically one addressable piece of content, and that would be the same piece of content that the first file that ever had 0 bits in it, like a block at the block level, that like there's somewhere a block with 0 bits all the way through, and the first one that was ever there is the one that's used forever. Is it like that?
Essentially, all of these things exist forever because math. So I will.
But my question is like a block.
The answer is yes.
A block that's common between like my PDF and your JPEG, they're shared.
Yes.
So it's really de-atomatized. Sorry, per host?
Per host, yeah.
Aha, see, the devil is always in the details.
Yeah.
What is a host in this case? Is that the browser, or is it?
So anytime that you have an IPFS node or the IPFS software running, it's not that there's only one copy of this on the entire network. It's per one of those nodes, whoever has it, which also may include they've recently looked at it and it's still sitting in cache, right? Then they have only one copy of that. And if there's 17 files that have the same block, they only store it once. But my computer and your computer might independently be storing that piece, which is what gets you those nice CDN-like properties.
So the same content address will appear in both places, and how it is cached and stored locally and where you fetch the individual blocks from is, again, part of the protocol.
Okay.
So as an example, lots of people will literally put the string hello world as one of the first programming things in there. No. I can guarantee you that hello world is very widely distributed in the IPFS network right now.
Yes, okay, it's very fast.
So if I were to put content into IPFS and I were the only person who ever viewed it and I disappear, does that mean that address space is taken but the content is lost forever?
No, it's kind of an interesting thing where essentially that the hash is the hash of the hash because math. If Boris.jpg, you put it in, you get a hash, you're the first and only person to do it. It doesn't take the space. If someone then finds a USB key that you tucked away in your safety deposit box and has Boris.jpg in it, and they plug it in again, well, it will still be the hash of Boris.jpg. So whether or not it is online is kind of a secondary effect. So the hash will remain persistent forever. Whether or not it is accessible, someone still has to keep it on the internet.
Yeah.
Okay.
It might be helpful for me to pop down one level.
Yeah.
So today we use location-based addressing, right? So you want to go to, I don't know, whatever, google.com/images/ whatever the path is. You go to DNS, you get the IP address, which tells you which computer to ask for. So you route there and you say, hey, give me the thing at this path, right? IPFS, so we now have a naming layer on top of a literal physical network, right? IPFS, or content addressing, says, well, we can do one layer on top of that, right? Where there's this special relationship between the data and its hash. So we can take a SHA hash, people are often familiar with. It's the same thing, the random bits you get off of a Git commit, where you run it through a hashing function, and every time you run that same data through it, you always get back the same hash. And the space of that hash is huge, right? It's like many times, the more than grains of sand on the planet, more than atoms in the observable universe kind of space, right? Massive. So having collisions is very unlikely, even though we are putting it into a smaller space, right? So if I hash a file and you hash a file, we get the same result. So it's not that you're reserving some piece of the namespace. This is the special relationship between the hash and this data. And now we no longer have to say, well, take me to that location and give me the thing that lives there, which is almost like saying, go to this house, into this room and grab the third book on the bookshelf. And that's the thing. We instead say, hey, who has the image that's associated with this hash or whatever the file is? And anybody could have it, right? So instead of going to that bookshelf and finding the third book on the second row, now you're saying, hey, who has a copy of War and Peace or whatever it is?
And it could be someone in the cafe that you're connected to. I mean, we don't do a lot of that these days with the pandemic going on. It could be someone in your local area. All of these things. So it's likely to be much more local. And once you've cached it. So all of this is to say so what this gives us, of course, is really unique capabilities. If you have files on your local machine, so they're present locally, you know that they can also be available on the server. They can be available on someone else's machine. You can go offline. And because of this uniqueness factor, you can know that the files haven't been modified, or you can take actions if they have been modified because the hash will change. So it actually adds a layer of trust because you're trusting that the hashing algorithm will remain the same. The math will remain the same. And that's a constant theme, right? That's how we're able to trust things where usually you're like, oh my God, you could just edit something on the client side on JavaScript. You could, except then it will change the hash. And this means that we can consistently use it everywhere. And we've taken that capability and essentially built an open source iCloud on top of it. So IPFS does not natively have a file system with metadata. You can do basic hosting of files with it. We've added, Brooks designed a file system that includes an encrypted area, and encrypted to be very secure and to hide metadata and include privacy, called the Web Native File System. So that's our kind of iCloud equivalent. But to get encryption, you need to create identity as well. And so that's what Brooke talked about, the decentralized identity system. UCAN is the protocol that we call it. And those things together all run directly in your browser.
Okay. And I'm just typing some of these acronyms out to the comments, and feel free to do that as well. So I'm still worried about like the life cycle of my files, or my data. Okay.
Sure.
So I've got Boris JPEG, and I'm writing a Fission app, and I publish my Fission app, but nobody's ever looked at it, and I cease to exist in the Fission world because you have this drive. Is it true that you're also taking a copy of that encrypted file if it's private with identity and persisting it so that like the next person who actually finds my app can still use it even though I turned my laptop off?
Yes. You're absolutely right. So when you're developing Fission app and you have everything running nice and locally, and you can serve it directly from your computer, right? And then you close your laptop and it's offline. So that namespace is still associated to all of those files, but nobody has a live copy. So
in the IPFS world.
In the IPFS world. So we run a IPFS node on our infrastructure, and then we will copy everything over, and it's now available. That doesn't mean that we can see the contents of the private files. Everything's encrypted on the client side, so end-to-end encrypted at rest, all of that nice stuff. But we make that available so that if somebody with the key wants to download it, then they can decrypt it on their side. Or if it's a public file, then they can anyone can grab that file directly.
So you're basically offering this for free at a small loss right now because you're also a company.
We're early. It's taken us about a year to put this stuff together. There's various things in the protocol. For example, we've got I think we're just over 1,000 users right now. I forget what the number is. And if for instance, we only need to store one copy of Hello World across all of those users, and that thing goes across it. So we actually have a cost advantage in storing all of these things because the protocol itself deduplicates everything. And the more that people run it, it's actually not fetching it necessarily from our servers. It's fetching it from whoever on the network has it. So having these like built-in CDN qualities. But yeah, that's part of our model. So just like you might pay for an upgraded iCloud account, whether you're a developer or an end user, you can pay Fission as part of that. But you can also store a copy yourself. So it's not just locked into our servers. It is traditionally and centralized to make sure that it's backed up and all that good stuff. But Brooke, maybe it's useful actually to talk about the DNS architecture. So IPFS is its own protocol, which isn't HTTP, but it has these really nice peer-to-peer product properties, and we're kind of connecting the two and making it so that you can make apps on there. DNS,
yeah. So before I get into the DNS stuff, it's exactly what Ori was saying earlier, right? It's like we've been trying to have these whole distributed decentralized systems for like forever, but because there's this UX challenge, they get less adopted, right? So we're very much trying to bridge that gap, make things usable and easy, while still giving people as much autonomy and control as we possibly can. And we only see that getting, we're really limited by what's in browsers. So we bootstrap some of this stuff up, people using our SDK, but there's some things like, if there's no copy of the file online, like, you're kind of at a loss then. So we make sure that the experience is good, right? So that the baseline is at minimum how things feel today. So DNS, we're using DNS in, it's not even particularly novel, it's just I guess a less common case. We're using DNS as a distributed key value store. with text records. So it's essentially our distributed Redis, right? So everybody's non-human readable name, ID, is stored in a text record that's associated with their human readable name. Every app has the top end of the app's file system. So the one bit that we didn't talk about IPFS a moment ago is it's not just each individual file. You can then stick those together in a tree or a graph, and then the root of that tree has its own address. So you can talk about an entire large structure with a single hash. So to serve an app, we put that in a text record, and that then gets grabbed when you ask for the regular DNS address, and served over HTTP for the first download, right? And same thing with the user's file system. So the user has their DID, essentially their public key, stored in a way that now people don't need to remember this random string. It's whatever boris.fission.name, and their file system as well. So that text record gets updated. The advantage of this, other than we don't have to keep everything ourselves, is it's very easy to federate with or interoperate with. You're no longer waiting around for a network request from us or getting gatekept by us. You can always get access to, well, what's the root of this user's file system? And then you can, crawl down through that.
That's fascinating, and I have a couple predictions based on that. Mm-hmm. But first, a question: at what point do you break the dig tool? Like, if I go and dig some top-level domain that you're running, I'm going to get millions of records.
No, not like that. It's actually per subdomain. So we Brooks done this amazing thing where we generate subdomains. Many systems do this already for your apps by default. So as an example, you might get something like benevolent senior pink yeti with hyphens between it .fission.app.
That's the one I want.
And basically there is then a text record at a subdomain there. And it has a single text record in it. So each one of those, just think of every address as having the current git commit equivalent in IPFS of the head of your publish is stored in there. And as we update, when you publish new versions, is when that comes up. We've lost Ron.
Yeah, and I'm
over to you, Ori.
About having gotten huge junior square queen. Junior square queen. Thank you. I think like as I was doing things on the keyboard, Brooklyn was on the other side typing the DNS thing, and got me a queen, a square queen. Maybe I'll ask another, because when I think about this, and it also feels like a bit of a thing waiting for full homomorphic encryption to really happen, because in a way we're kind of feeling that but this is gonna break on indexing, on search. If I'm gonna have an app that is going to have 1 million users in it, and I want to be able to exchange and interact with the media. So how much of this only goes, wow, when we get there? And do we get there, by the way? Do you think we're getting there?
Yeah. I love how we went from, can you define JWT, to fully homomorphic encryption in 20 minutes.
Speed dating.
So FHE, super exciting. A few years off before it's really practical at speed. So the short version is, so for private files, you can still grant access to others to look at, index, etc., or to do, run some additional analysis over top of. But especially for things like an app, all of that will be, anything that's public is public, right? And anything that is shared amongst some subset of people is probably not massive data, right? There are cases where that happens, but sort of the 99th percentile isn't. So, at some point, will there be use cases for something like fully homomorphic encryption? Will that be super cool and make a lot of these things easier? Totally, right? In the meantime, it's, again, remember that this whole model is flipped. So it's whatever the individual user is allowed to see. So it's them and their friends in a group, or them and their company. So let's call it 5,000 people, right? So you need to be able to index into 5,000 portions of a private file system. That's really not that much data to handle, as opposed to today's model, which is you have to index literally everything. And so this multi-tenancy in a traditional system is a big part of the reason why you need such scale, massive servers, big systems, right? And by breaking things up in this way, we've really taken almost horizontal scaling to the maximum, right?
Yeah, and it's kind of most of the problems will everybody's talking about it these days, like compliance and GDPR, and they just go away because
exactly. So this is what happens is, as a developer, you usually, the first thing when you're setting up an app is you have to add accounts, and then you have to add business logic, and you have to hope that you write that business logic correctly to keep database tables and Boris.jpegs on a file system separate from other users in the system. And if you want to, create an audit log and make it so that Robert can't log in and edit the database without other people knowing, those are all things that you have to add to a system. So right now, building a Fission app, you basically just say the user, the app gets the access to who is the current user, and is automatically scoped to just that user. It also means that your database can be like a single JSON file at a small scale. So for making simple single user apps and utilities, much like the early days of the App Store of native apps, all of that is brought in by the environment that you're brought in. On the flip side, what we're doing is we're moving data next to where compute happens. Again, instead of it all being centralized over there in a server, you essentially have access to the entire global IPFS namespace all the time, everywhere. The data might not be local to you at any point in time, so if you need to do processing on it, but it also means that everyone can compute different pieces, and you can fetch the data as needed and bring it in. So our next step is, in fact, doing some challenges around graphs and more database-like facility to do those big indexes and shared things and so on, and improve that experience so that, again, we can just say, okay, you want to add 1,000 users? Cool. Web native.database add, done.
And anyway, potentially as a reminder, there aren't that many use cases for big data other than in bioinformatics that are not evil. Like everything else is just time series and time series of user interactions. Nothing else generates gigabytes, even gigabytes. Like video, and not even even video, it's like one, right? And now we're long film. So in a sense that when you remove evil from the equation, you don't need a peta-level storage ever, and your phone is probably a supercomputer enough. I mean, it has an incredible GPU on it.
Yeah, I was talking to somebody a couple of weeks back who was saying, well, while we're building this, globally distributed database, what can I do in the meantime for just my data? It's literally throw it into a JSON file and filter over it when you need to find stuff, because it'll be faster than making the network request, like by an order of magnitude, right?
Yeah, and there's a question from Larry, and I think that that's very much the answer. Most problems can be handled. I mean, like there are gigabytes of memory on this, and gigahertz of faceting is trivial when you do an in-memory transformation, it's just, it becomes an, it's only hard when you have millions of stuff, and millions is not normal. It's rare, extremely rare to have real world problems that have millions in them.
I know we have dozens of rows, right?
So I'm going to say yes, but also, what if we can connect some of the open data that's out there to not have to redo it? So Brooke, maybe that's useful to talk a little bit about the graph database and IPLD capabilities that you're thinking about in our database design.
Sure. Yeah. So this is all future-facing, still in very much in development phase. So we have this constraint where there is no central single database, right? And some of the data is available to some people and not others, or a lot of it, right? How do you do, and then there might be network partitions, people might be coming online, offline, and you need to always be live on the app, whether or not you're connected to the network, right? So how do you even make that work? The system that we've designed essentially lets you merge in changes that you're allowed to see. Which is to say, somebody might have some private changes that you're also not going to see, right? But basically merge that into a database locally. These can be as granular or as aggregated as you like. You can stick them together and pull them apart as needed, and compute over those locally. This is all based on two systems. So CRDTs, which is a kind of way of doing distributed updates to data, and data log. So instead of having things stored in tables and rows, you still have the ability to represent them as tables and rows, but also as a graph or as a key value database or any of these things. And so it ends up with this very nice natural way of talking about whatever the kind of data that you're trying to access in a natural way for that, without having to go through many, many different kinds of join tables, et cetera. You can still stick a SQL interface on top of that, but we think people will especially be quite excited about the graph capabilities of such a system. And having it be, especially the part where you can stick things together and pull them apart, means that for your specific use case, you can say, well, I only want the bits that are going to apply to this use case, even though I have the store of all rows over here. I can pull this apart, and now I only have to compute on this piece, almost like a table view or pre-computed query.
So as an example, go ahead, Ori.
No, I'm going to plug in the competition. And I think that's part of the interesting thing is that, and that will, tell that this is a thing happening, right? This is a movement. So concordant.io is coming from a similar mind space, and it's something done by Mark Shapiro, who's the author of the original CRDT paper. Mm-hmm. And I think it's really, really amazing. Everybody should meet, by the way. Sorry, Boris.
I was just going to say, so bringing it back down to some of the things you can do. Remember, our use case here and how we're thinking about it as customers is front-end developers. So all of us have a fair amount of full stack experience and are old when we had to run our own DNS and stuff like that. Those full systems experience. And now, because of the complexity of the internet and really the hostility of the spaces that we're in, it's so hard to do all of these things. So, we want to kind of make some of these things easier. So as an example, with a file system, what you might want to do is show me all files that are images. So not in a particular folder, but just query the entire file system that the current user has access to. Remember, capabilities based, not even just in this particular folder, but wherever the permissions exist. And so these are sorts of things that you can do. And all of a sudden you've got this view that says you can loop over all of the images available in the entire file system. for those of you on something like Mac OS or Windows, you can actually do views where show me images. So a lot of these capabilities end up feeling a lot more like a desktop or native mobile operating system. And we really hope that this will have like an explosion of people building, really interesting personal apps of various ways because the building blocks are there.
Yeah, which is maybe a subtle point that's worth highlighting, right? Again, this multi-tenancy versus single user view, right? It's not now that you have to do an entire table scan looking for the things that this user has access to. Everything in your table are things that this user has access to, right? So the model is different again. And if you can see things that another user's created, you have a direct link to it. And you've probably copied that into your system, right? So it's always scoped to what the current user is allowed.
And I think potentially, sorry, it's worth, we've gotten used horribly enough to SaaS and to its constraints, to its inefficiencies, to how damn slow stuff is. Everything, and we're okay with it, and we, and a lot of these SaaS things now we kind of we feel they're fastish, although every time when I'm on my computer and I'm using the command line or I'm using, it's we are a factor of difference between how they operate and and we've accepted it, and this is a horrible degradation of the experience, and they won because they won by scale, right? But an unnecessary scale, and as a matter of fact, very probably you'll show your images faster, right, than on Google Drive. Show all your images because it's local. Co-location of data and computing.
Exactly. So that's a great phrase, Ori. Co-location of data and computing, and breaking those teams apart and recombining them in different ways. Whether you're bringing data to computing is the stuff that we did before, where we're like, well, it can be a little more flexible. If your local machine has your local client has lots of compute, we can do lots of compute. But at the same time, if you're offline, we need to compute for you. Or if you need to do a really big job, what if we can do it? So we're not doing compute today, but that's what we're thinking about in the future as well, for sure. I think the SaaS model, I wanted to touch on you saying that, where the SaaS model in part implies both an architecture and a business model.
Yeah.
We want to empower developers to, in fact, spend more time having a really great experience for their users. Again, on the web, but more like a native desktop or mobile app, where you're not having to worry about all of these other pieces. You can really work on the user interface and some of the interactions that you do. And you can still have a subscription business model of saying, hey, do you want to pay for this monthly or yearly? But you're paying for it not with leaking your data. You're paying for it because you're like, this is a great app. I want the developer to keep working on it. And you don't have to worry about, oh God, hopefully that they keep my data around. Hopefully they don't use it. Hopefully they don't look at it. Or things like, geez, I hope it doesn't go away or go down, because you've got this local copy of it. There's no concept of exporting your data, because the data is available to the user from day one. You don't have to hope that someone building a Fission app adds an export feature, because it's built in, which is why it's GDPR compliant out of the box.
Yeah.
And by the way, and here, sorry, very interesting in a way, Fission basically as a company here presents itself as kind of the perfect utility. This is what we, what we were hoping for is for utility computing. What we got are, monopoles and oligopoles that and they also do the utility, but it's like what do you get? Another day older and different debt, and they own you, right? Instead of it's really weird, the world where the utility owns you. I kind of ask people, are you owned by Apple or are you owned by Google? Or are you owned by both? And this is, basically a non-evil take on the SaaS model.
Yeah.
I'll take it.
Yeah, but rewinding back to the implication of business model and architecture and all these things. I think it's pretty, when you take a step back and think about it, how did we end up in this position in the first place, right? In 1994, having a client-server model totally made sense, right? And we've been making small iterations on the LAMP stack, right? And we've ended up in what I believe, at least, is a local maxima. And if we take a step back and go, okay, well, there's 20, 25 years of computer science that's happened in between, and fundamental changes in computing, like having a supercomputer in your pocket, right? What would that landscape look like if we were to not start from scratch, because we have to be completely compatible with how things are today, but what are some advantages that we could change now? And that's really where we started from at Fission.
And where this is heading as well, and Concordant actually, I think, shares a lot of that if you look at their website as well. We've had some recent discussions, and we're still, saying like Fission helps you build edge apps or web apps, and all of these are a little like, what exactly does that mean, right? The couple of things happening at the same time, right? There's the document web that's content and blogs and reading with relatively limited interactivity, and then there's things that are apps. That are SaaS apps, that are React, that you interact with and you do custom data and visualizations, or even things like games. And we see that app web is something that we are supporting. We're supporting it with advanced browser capabilities. The next version of Microsoft's Outlook is going to be a web-based version that they also install on your desktop. So we encourage progressive web apps, PWAs, when people are building things that are truly apps with Fission. As you push stuff to the edge, you have no choice if you want to add personalization and state, but to have a distributed version of that. As we have more 5G and low latency is the thing that becomes really valuable, you can't call back to a Drupal or WordPress database, which is at US East, a continent away. You have to put some of this stuff closer to the edge. So Concordant has some of these things with CRDTs. We're working on a similar stack. We want to build these building blocks that are available. So we're really excited about where some of that stuff is heading. It's interesting to read material from Google that says they had these same problems at scale. And Fission is putting a toolkit together both for small apps and developers, but also solving really, really big problems as well, which ultimately look like distributed systems. And other than that, I think really excited by what's coming from browsers. So many more capabilities. We wish it worked more equitably across all browsers, not just Chrome. There's the Fugu project of adding all sorts of things. One of the people on our team actually built a Fission app where you plug a MIDI keyboard into your browser and then store synth patches on your Fission file system, which is pretty cool. And WebAssembly is the other big piece. We talked a little bit about compute, and we see that bringing that much more power and capability to browsers. And that's why we make all of this stuff work without plugins, without extensions, and making it compatible so that it works on mobile phones as well.
So as we come to the top of the hour, I want to thank you both for sharing so much of your Fission vision and explaining what was really a lot of new concepts and terms for me the first time that I looked at it. I do have one maybe final question that might also be on the audience's mind. Is there a URL, an example that we can just click and go to and see a Fission app, a live Fission app, and what that looks like, and maybe one of the most exciting ones you can think of?
Yeah, sure. We'll send you to drive.fission.codes, which is basically our first-party app where you can browse your entire Fission file system, and it's meant to be, once it loads and once you've signed up, to be really snappy, and you can just drag and drop files into it. You can put them in your private file system, which is fully encrypted, or anything that you drop in your public folder is pretty much instantly available There's even a little basic plain text editor. So you could even author a little HTML file. It'll be live right away.
Sounds awesome.
So definitely,
what does it cost?
So currently we're essentially in an extended beta. You can go ahead and start trying it today. We will start charging and give you a certain amount of storage for free, and then charge for keeping things online and backing things up. And that's just one of the capabilities. So you can browse actually any other app data that other developers store. You can directly browse. So on macOS, that would be looking in your libraries folder for things that's stored on disk for you.
Wonderful. Thank you so much, both of you, for joining us today, and Ori for being our special co-host and bringing your excitement for distributed web along with you. And we do this every week, people, so tune in next week for another episode of Deploy Friday. Thank you, Boris and Brooklyn. It was a pleasure talking with both of you. Bye-bye.
Thanks so much, Rob. Good to see you,
Thanks
Rory.
for having us.
Thank you. Bye-bye.